Hello and good day everyone. Okay, we meet again in Laplace transform chapter. In this video, you're going to learn how to find the Laplace transform using first shifting property. So the learning outcome of this video, you should be in the end of this video, you should be able to find the Laplace transform using first shifting property. Okay, here is the definition of first shifting property. So the Laplace transform of the function ft equals exponent at times gt. So we can see that the type of the function is a multiplication of a function gt by exponent at. Here gt can be either plus of gt. Alright, so if we have this function exponent at times gt, okay, then you determine the gt. Alright, find the Laplace transform of gt, you're gonna get gs. Okay, then you shift gs to gs minus a. So that's why this property is called first shifting property. Okay, so let's take a look at this example. You have Laplace exponent 2t multiplied by t. And from the exponent, we can determine that a is 2 and the function gt is t. Right, gt is t. So the Laplace of the exponent 2t multiplied by t equals g, okay, in s domain at g s minus 2. Alright, so before you do the shift, before you can determine the gs minus 2. Alright, you have to find what is the Laplace transform of gt to give you the information about gs. So the gs equals Laplace gt, and we know that gt is t, so Laplace t is 1 on s squared. Alright, then we do the shifting because we know that the Laplace of the exponent to t is g s minus 2. We have determined the gs, which is equal 1 on s squared. So therefore, the Laplace of exponent to t multiplied by t equals g s minus 2, and this is equal 1 over s minus 2 squared, where you just need to replace s by s minus 2. Okay, here is another example. So Laplace of exponent for t cos 2t. Alright, so a is 4 and gt is cos 2t. Alright, so Laplace of exponent for t cos 2t is gs minus 4. How do you get s minus 4? Because of the the power of the exponential is 4. Okay. Alright, then find gs. So gs equals Laplace gt, and gt is cos 2t. So Laplace cos 2t is s on s squared plus 2 squared, which is s on s squared plus 4. Okay, then in order to find the Laplace of the exponent for t cos 2t, okay, we need to shift the gs to gs minus 4. So you just need to replace s by s minus 4. So s here now is converted into s minus 4, and s here also we need to shift to s minus 4. So this is the final answer for this Laplace transform. Okay, Laplace of exponent for t cos 2t is equal to s minus 4 divided by s minus 4 squared plus 4. Okay, now let's solve this question. Find the Laplace exponent minus t sine pi t. Okay. Okay, from the question, the first term is the exponent minus t. Then we can know that a is minus 1, and the sine pi t is the function gt. So therefore, the Laplace of exponent minus t sine pi t is equal g s plus 1. Right. Find the Laplace of g. So the gt here is the sine pi t. The Laplace of sine pi t is pi divided by s squared plus pi squared. Therefore, the Laplace of exponent minus t sine pi t is equal gs plus 1. We're going to shift gs to gs plus 1. We're going to replace the s by s plus 1. So we're going to replace s by s plus 1. So this is the final answer. Okay, let's try to solve question 1, 2, and 3 in this exercises page. Okay, I'm going to leave it to you guys for solving the question 4, 5, and 6. So basically, when you look at the question of 1, 2, and 3, so these are the general solution, okay, to the first shifting property that involve all types of function where exponent when exponent multiply by the polynomial t to the power of n, the exponent multiplied by the cosine function, and the exponent multiplied by the sine function. Alright, let's try to solve the first question where you need to find the Laplace of exponent a t to the power of n, and we know that this is equal g s minus a. Right, and the tn here is the gt. So next step, we need to find the gs, Laplace of t to the power of n, and this is equals to n factorial divided by s to the power of n plus 1, right? How do you know that? From table of Laplace transform. So therefore, the solution, okay, the solution of the Laplace exponent a t to the power of n equals, okay, so you need to shift the gs to gs minus a. Then this is equals to n factorial divided by s minus a to the power of n plus 1. So every time you need to find the Laplace transform of exponent a t multiplied by t to the power of n, so this will be the general solution. So means here you need just need to substitute the values of n, okay, based on the power of the t, and also the value of a based on the power of the exponential. Alright, now let's move to the second question. I'm going to use green pen color. Okay, so number 2, the Laplace of exponent a t cos bt, and this is equal to g s minus a. Right, while gt is the cos bt. Alright, gs is the Laplace of gt, which is cos bt, and this is equal s divided by s squared plus b squared. Alright, so the g minus a, okay, we're going to shift gs to gs minus a equals s minus a divided by s minus a squared plus b squared. So every time if you want to determine the Laplace transform of the multiplication of exponent a t with cos bt, all right, so this would be the general solution. Okay, just need to replace a by the power, okay, of the exponent, okay, and b is the angle of the cosine. All right, last but not least, I'm going to solve question 3. Okay, I'm going to use red colors. Okay, 3 Laplace of exponent at sine bt. Okay, I hope that you get the idea. So this is gs minus a. Okay, how to determine a? The power of the exponential function. All right, and then okay, from here sine bt is the function gt. All right, and gs is equal the Laplace of sine bt, and this is equal to b divided by s squared plus a squared. Alright, so g s minus a is equal b over s minus a squared plus, okay, I'm sorry, I made a mistake here, supposed to be, this is b, not a. Okay, s minus a squared plus b squared, okay. So shift, where here is where you're going to see the shifting operation, where you shift gs to gs minus a. Alright, so every time you see the question of exponent at multiplied by sine bt, the Laplace transform of this function is equal to this answer. Alright, you just need to replace the value of b and the value of a. So I've shown you the general solution of three types of functions that will involve exponential function, exponent at. Alright, thank you so much.